Hello everyone, welcome to the lecture. Myself Devananda Rao, working as Associate Professor in the Department of CSE, MLR Institute of Technology, Hyderabad. Today's topic is phases of the compiler and pass and phase of the compiler. Phases of the compiler. A compiler operates in phases. A phase is logically interrelated operation that takes source program in one representation and produces output in another representation. The phases of a compiler are shown in figure below. There are two phases of compilation, that is analysis phase and synthesis phase. Analysis phase is machine independent or language dependent. Synthesis phase is machine dependent or language independent. So, broadly dividing the compiler phases into two parts, one is analysis phase, another is synthesis phase. Next, compilation process subdivided into number of sub-processes called phases. See this. We have 6 phases: lexical analyzer phase, syntax analyzer phase, semantic analyzer phase, intermediate code generation phase, code optimization phase, code generation phase. We have 6 phases. All these 6 phases are connected to syntax table management or error routine, symbol table. We will discuss phase by phase. Lexical analysis phase, first phase. Lexical analyzer phase is the first phase of compilation process. It takes source code as input. It reads the source program character by character, that is one character at a time, and converts it into meaningful lexemes. Lexical analyzer represents these lexemes in the form of tokens. So, for example, sum is equals to old sum plus 50. This is a statement, source program statement. This statement is read by the lexical analyzer, scanned by the lexical analyzer, and reads the character by character at a time and find the lexemes. Here sum is a meaningful word, is a lexeme, old sum is a lexeme, plus is a operator, 50 is a number, like that. So, it will find the meaningful lexemes. These lexemes are represented by in the form of tokens. Here sum is identifier. Sum is identifier. So, here identifier is a token. Next, syntax analysis. Syntax analysis is the second phase of compilation process. It takes tokens as input and generates a parse tree as output. In syntax analysis phase, the parser checks the expression made by the tokens is syntactically correct or not. Here syntax analysis takes this sequence of tokens as input and generates the syntax tree and checks the any syntax error are there. Next, semantic analysis. Semantic analysis is the third phase of compilation process. It checks whether the parse tree follows the rules of language. Semantic analyzer keeps track of identifiers, their types and expressions. The output of semantic analysis phase is the annotated parse tree. Here the semantic analysis checks for meanings. Here it will keeps track of identifiers and the type of the identifiers, whether integer or character, whether basic type or constructor, like that. It will keeps track of identifiers and their types and expressions. They will checks for meanings, meaning of the expressions, meaning of the identifier and types of the identifier. If any mismatch occurs, type a mismatch occurs, they will give the error. Next, intermediate code generation. In the intermediate code generation, compiler generates the source code into the intermediate code. The intermediate code is generated between the high level language and the machine level language. The intermediate code should be generated in such a way that you can easily translate it into target machine. Here we have source code, source program as well as machine code. Between source program and machine code, we have intermediate code. So, this intermediate code can be easily converted into machine code. We have different types of intermediate code. Intermediate code can be represented by syntax trees or 3-address code or postfix notation. These are the 3 representations of the intermediate code. Next, code optimization. Code optimization is an optional phase It is used to improve the intermediate code so that the output of the program could run faster and takes less space. It removes the unnecessary lines of the code and arranges the sequence of statements in order to speed up the program execution. Here unnecessary statements will be removed from the code to improve the code, to optimize the code. That is, for example, dead code elimination. Dead code means if the whenever we say the code is live means we can use that code, any statement, any initialization, we can use that initialization or statement in subsequent basic blocks, that is code is live, otherwise the code is dead. So that we can remove that dead code to improve the code. Next, code generation. Code generation is the final stage of the compilation process. It takes the optimized intermediate code as input and maps it to target machine language. Code generator translates the intermediate code into the machine code of the specified computer. Here, code generator is the last phase of the compiler. It takes the intermediate code as input and produces the target code as output. Target code may be machine code or assembly code. So, if the target code is assembly code, we need to convert the assembly code into machine code by using assembler. Next, for example, this is the example. Here, sum is equals to old sum plus rate into 50 is a statement, high level language statement, that is given to the first phase of the compiler, that is lexical analyzer. Lexical analyzer read this statement character by character and gives the lexemes, sequence of lexemes. These lexemes are represented by using tokens. Here identifier 1, identifier 2, identifier 3, identifier 4 are the tokens. Identifier 1 is sum, identifier 2 is old sum, identifier 3 is rate, identifier 4 is 50 number. Here star plus are the operators. Then the output of the lexical analyzer is sequence of tokens. These sequence of tokens are given to lexical syntax analyzer, second phase of the compiler. Syntax analyzer takes the sequence of identifiers as input and construct the syntax tree or parse tree. Here first rate into 50 is evaluated, that is rate into 50. Rate means identifier 3. Identifier 3 is multiplied with 50, identifier 4. 50 is identifier 4. Identifier. So that is added to old sum. The result of rate into 50 is added to result of rate into 50 is added to old sum. Old sum means identifier 2. So the result of old sum plus rate into 50 is assigned to sum. So this is the parse tree or syntax tree. This syntax tree is given to semantic analyzer as input. Semantic analyzer will check for meaning. Here this is a annotated parse tree. Annotated parse tree or syntax tree. Here 50 is an integer, but if you want to convert this 50 into real, by using this into to real we can convert. Next, this annotated parse tree is given to intermediate code generator as input. Intermediate code generator takes this annotated parse tree as input and gives intermediate representation. Intermediate representation are three types. So we can represent intermediate code in the form of syntax tree or in the form of 3-address core or in the form of postfix notation. So here in this example, this intermediate code is represented in the form 3-address code. 3-address code means 3-address code means at most 3 addresses will be there in the statement. At most 3 addresses will be present in the statement. See, temp 1 is equals to into 2 real of 50. We are converting 50 into real, into 2 real by using the function into 2 real. 50 is converted into real. That is assigned to temp. Here we have two addresses, at most 3 addresses should be there here, but at most 3 addresses means we can have 1 address, 2 address, 3 address. So here 2 addresses. Next, temp 2 is equals to identifier 3 into temp 1. Next, temp 3 is equals to identifier 2 star temp 2. So identifier 2 means identifier 2 is old sum, temp 2 is identifier 3 into 50. So old sum, this is not plus, this is not star, this is plus. Old sum plus rate into 50, that is assigned to temp 3. Then finally identifier 1 is assigned temp 3. So this is intermediate code of the source program. Next, this intermediate code is given to code optimizer to optimize the code. So code optimizer will remove the unnecessary code. Here unnecessary code is we can remove this into real by writing temp 1, it is a temporary variable, is identifier 3 into 50. It is we need to convert this 50 into real, that is 50.0. So we can remove this statement. Directly you can take the result of identifier 3, that is rate into 50 is multiplied and stored in temp 1. Next, identifier 1 is equals to identifier 2 plus temp 1. So only two statements are reduced. The intermediate code is reduced to only 2 statements. Next, this optimized code is given to code generation. Code generation will give the target code, whether it is machine code or assembly code. Here assembly code is move f identifier 3 comma r2. R2 is a register. Identifier 3 will contain rate. Then mul means multiplication. 50.0 is multiplied with identifier 3. Identifier 3 is available in R2. So 50 is multiplied with identifier 3 and result also stored in R2. Then move f identifier 2. Identifier 2 is old sum. Old sum is moved to R2, not R2, R1. Take another register R1. Now R1 will contain identifier 2. Identifier 2 is old sum. Then add f R2 comma R1. R2 will contain rate into 50. R1 containing old sum, both are added and result will be stored in R1. Then finally move R1 comma identifier 1. The result of old sum plus rate into 50 is stored in identifier 1. Identifier 1 is sum. Like that the phases of compiler will work. Next, pass and phases of the compiler. A compiler can broadly divided into 2 phases based on the way they compile. We have 2 phases, analysis phase and synthesis phase. So analysis phase is also called as front end, synthesis phase is also called as back end. Then analysis phase will take source program as input and gives intermediate code representation as output. Synthesis phase will take intermediate code representation as input and gives machine code as output. Analysis phase will contain lexical analysis, syntax analysis, semantic analysis and intermediate code generation phases. Synthesis code will take intermediate code as input and gives the target code as output. Analysis phase known as the front end of the compiler, and analysis phase of the compiler reads the source program, divides it into core part and then checks for lexical, grammar and syntax errors. The analysis phase generates the intermediate representation of the source program and symbol table, which should be fed to the synthesis phase as input. Then synthesis phase known as the back end of the compiler, the synthesis phase generates the target program with the help of intermediate source code, representation and symbol table. Next, pass and phase. A pass refers to the traversal of a compiler through the entire program. So, if you traverse the entire program once, that is called one pass. Phase. A phase of a compiler is a distinguishable stage which takes input from the previous stage, processes and yields the output that can be used as input for the next stage. A pass can have more than one phase. Like we have the lexical analysis phase. First phase, it takes source program as input and gives the output as a sequence of tokens. So, it takes one form of program as input and gives another form of program to the next phase. So, a pass can have more than one phase.